In this video, I'm going to cover the first part of Section 1.3, Sampling Principles and Strategies. In my next video, I'll cover the second part of this section. So let's say you're interested in the population of all college students. What parameters about college students might a researcher be interested in knowing? So remember that a parameter is a piece of data or a number that describes all college students. So for example, a researcher might be interested in knowing the average amount of money spent on books each semester. They may be interested in the average amount of money spent on clothes or takeout food. A researcher might be interested in the percentage of students who smoke cigarettes. Maybe some health organization is interested in this piece of data. A researcher might be interested in the percentage of students who commute to campus. For example, a university might be interested in that piece of information if they want to maybe redesign some parking lots. If a high number of people commute to campus, it makes sense to redesign the parking lots. A university might be interested in the average level of satisfaction with student health resources, or the average number of hours spent studying per week. There's so much information you can extract from the population of all college students. This is just a few things, and there's a whole lot more. So you can see that some pieces of information may be important to different businesses or different groups of individuals. Now let's think about how we could build a sample of college students to help us estimate these parameters. My first question would be, how large should my sample be? So it makes sense that the larger the sample we have, the better estimate of a population parameter. Remember that we can actually never figure out, let me go back to the last slide, all of these averages and percentages, I will never be able to find the precise numbers for these. And the reason for that is I don't have a spreadsheet where I have all college students listed. If I had that, I could estimate all of these parameters. But the population is so large, I cannot put every student on the spreadsheet. So what I'm going to do instead is I'm going to build a sample, and I'm going to try to make that sample representative of the population. And the reason for that is I want to calculate statistics, which are pieces of data that summarize the sample. And if my sample is representative of my population, then my statistics should be near the true parameters. So we want to know how many people we should put in our sample. And it makes sense that the larger the sample is, the better estimate of our population parameters. But a larger sample requires time and money. You have to spend a lot of time to find these people, to ask them questions, and you also have to hire, especially if you have a big sample, you have to hire people to ask questions to the sample to build your database. So you may want to know, is there a minimum number of people I can put in my sample in order to estimate my population parameters? And it turns out that there's no perfect number that works in all situations. It depends on how big your population size is. If it's very large, you would want a bigger sample. It also depends on what you're trying to find. Like if I'm trying to find a percentage, I have a formula that we're going to see later in this class that works for percentages, and I also have like a formula that works for averages. So for us right now, we want a baseline. The baseline will be about 30 observations. Now, if you have a very large population, some statisticians say about 10% of the population is a very good sample size. Okay, so we know we need maybe around 30 people to build our sample. But how do we choose people to put in the sample? So there are 4 basic sampling methods that will give us a representative sample. What that means is, when I say representative sample, is it's a little mini population, has all the same characteristics of the original population. So the first way is something called simple random sampling. That's where each person in the population has an equal chance of being included in the sample. For example, drawing names out of a hat or using a computer to randomly select cases from a database or spreadsheet would be examples of simple random sampling. What are some pros and cons of this method? So a pro would be randomly selecting cases removes the chance of any bias that may occur when researchers choose who to put in the sample. Everybody has their own personal biases, and they may not even be aware of them. And if we allow researchers to just go around and what they think is random, just choose people to put in the sample, it may not end up being representative of the population. Asking a computer to do it, there's no bias there, and so they would probably make a computer would probably make a more representative sample. Now, a con is if the population is very big, it may be impossible to create a spreadsheet with everybody's name on it, like the population of all college students. If we don't have a spreadsheet with everybody's name there, not everyone has an equal chance of being included in the sample. But what if we want to do random sampling, but we don't have a big spreadsheet? Can we still do it? So for example, let's say you want data about people living in New York City. Obviously, we do not have a spreadsheet for everyone living in New York City. But how can we create a sample using simple random sampling? Well, what we can do is we can try to make a simple random sample the best way we can. And that is, we try to keep things as random as possible. So for example, we can approach random people on random selections of streets at random times. We can call randomly generated phone numbers at random times of the day. We can mail out letters to randomly selected addresses from randomly selected regions. And if you have like a list of email addresses that you know are for New York City, you can email randomly generated email addresses. So the point here is not perfect, but we can try our hardest to keep everything random to create a simple random sample. Now, the second type of sampling method that we're going to see is stratified sampling. That's where we break the population into groups called strata. So strata is one group, and the plural for strata is stratum, and you'll see both strata and stratum here. So the second sentence says, the stratum are chosen so similar cases are grouped together. Once we form our groups, we use simple random sampling in each strata to build our sample. So for example, if we're interested in all college students, you see this little image on the right, we could break the groups into freshmen, sophomore, junior, and seniors. So all of these groups have something in common. The first group, they're all freshmen. The second group, they're all sophomores, and so on. You could also break them based on age. So if you're interested in college students, you could have people 18 and under, people between 19 and 20, between 21 and 22, 23, 24. It doesn't matter how many groups you have. You just want the groups to have something in common. Job role, you could break them into two groups, whether they have a job, a part-time job or a full-time job, and whether they don't have a job. You could break them into income levels. There's so many ways to break a population into groups, but you want the groups to have something similar. Now, each group, the people in it have something in common, but when we look from a distance, the groups themselves look different, okay? This is important about stratified sampling. So let me repeat, the people in the groups have something in common, while the groups as a whole look different from each other. We're going to see the opposite of this in the next example of sampling. When would we want to use stratified sampling? So you see that instead of just having a whole population and using simple random sampling, like our first method, we're breaking the population into 4 groups here, the freshmen, sophomore, junior, and seniors, and then we're using simple random sampling. It seems like an extra step. Why would we want an extra step? And the reason is we may want to make sure certain groups are represented in our sample. If we have a very large population and we're just taking a small portion of it to make our sample, certain groups may not be represented when we use simple random sampling. But if we want to make sure those groups are there in our sample, by breaking them up and taking a little bit of each group, we make sure that the groups we're interested in are in our sample. Let me give you an example. The president of DePaul University wants to conduct a survey to determine the community's opinion regarding campus safety. There are 21,909 individuals in the population. He wants to survey 200 people. Okay, 21,000 is a lot of individuals, and 200, that's a small number compared to that 21,000. In fact, it's about 1% of the total population. Because the amount is so small compared to the population, we may miss when we ask a computer, like if the president has a spreadsheet of all the individuals at the university, it may miss certain groups. So, for example, the president knows that the university is made up of resident students, non-resident students, and staff. And you see we have numbers that represent how many of each group we have. So instead of asking the computer to randomly select 200 people, we can take our population, break it into resident students, non-residents, and staff, and then we can ask the computer to randomly select a certain amount of people from each group. Now, how many people from each group? Remember that we want our sample to be a mini population. So we should find the proportion of resident students, non-resident students, and staff, or the percentage of students versus staff. So for example, if I take that number 6204 and I divide by 21,909, I'll get 0.28, which means 28% of the university is resident students. And if I take that number 13,304 and divide by 21,909, I'll get 0.61, which means about 61% of the university is non-residents. And if I take 2401 and divide by 21,909, I get 0.11 or somewhere close to that, which is about 11%. So 11% is staff, 61% is non-residents, and 28% is residents. So what I should do is I should take 200 and multiply by these percentages. That tells me how many people I should take from each group. So 0.28 times 200 is 56, 0.61 times 200 is 122, and 0.11 times 200 is 22. So when I have my 3 groups, I'm going to go to the residents portion, and I'm going to ask a computer to randomly select 56 residents. And then I'm going to go to the non-residents and ask the computer to randomly choose 122 non-residents, and then ask the computer to choose 22 staff. And that's how I'm going to make my sample. The next type of sampling method we have is cluster sampling. This is where we break the population into groups called clusters. Once we form our clusters, we randomly pick a fixed number of clusters and include all cases from each of the clusters in the sample. So here in this picture, I have 9 clusters. I have a population, and what I'm doing is I'm breaking them into 9 pieces. And I randomly choose, it depends on how big you want your sample to be, but in this example, I randomly choose 3 clusters. And what I'm going to do is everybody in the cluster, goes in the sample. Okay, so everyone, that's why all is in red. Everybody in the cluster goes in the sample. Each cluster is diverse. Each cluster as a whole looks similar to the next cluster. Let's compare this with stratified sampling. In stratified sampling, we broke the population into groups, just like we did here in cluster sampling. We broke them into groups. But in stratified sampling, the people in a group look similar. In cluster sampling, the people in the group are diverse. They don't have something in common, except maybe they all live in the same place. But the people in there are diverse, which means each group looks like a little mini population. Okay, and because each one looks like a little mini population, in the clusters, they all look similar. The groups themselves as a whole look similar to each other. In stratified sampling, the groups as a whole look different. So it's like the opposite of stratified sampling. When would we want to use cluster sampling? Why would we take a population and break it into mini populations? We wouldn't do that normally, but sometimes it naturally occurs. So, for example, if you're interested in all city residents in America, there are certain cities that look similar to each other. And instead of taking everybody's name and putting them in a spreadsheet, you can just go to those cities and get people from those cities. So you're taking advantage of something that naturally occurs. This is called cluster sampling. Suppose we want to estimate the malaria rate in a densely tropical portion of rural Indonesia. We learn that there are 30 villages in that part of the Indonesian jungle, each more or less similar to the next. Suppose each village has about 400 villagers. What sampling method should be employed? Okay, from the three that we've seen, you could probably use all three in any way you want to do it, but there's one that's best suited for this situation. The one that's best suited is cluster sampling. That's because we're told in the problem there are 30 villages and they're more or less similar to each other. That means there's little clusters that all look kind of alike. Remember that stratified sampling is when the clusters look different, or the strata look different, the groups. We have one more example of sampling, and it's not really a new sampling method. It's cluster sampling, but on a budget. So multi-stage sampling is where we break the population into groups called clusters. Once we form our clusters, we randomly pick a fixed number of clusters and randomly include some cases from each of the clusters to make our sample. In cluster sampling, we used all cases. In multi-stage sampling, we use some cases. So you can see this is the same picture from cluster sampling. The difference is in cluster sampling, when we selected cluster 3, 4, and 8, we used everybody in there. But this time you can see that there's the red dots represent the people we choose to put in our sample. So this is the same process as cluster sampling, but instead of taking the entire cluster to form part of the sample, we only take a portion of the cluster. When would we want to use multi-stage sampling instead of cluster sampling? That's when we have budget and time constraints, especially if our population is very large and the clusters themselves are going to be very large. We wouldn't want to take everybody in the cluster. So we would want to use multi-stage sampling instead. Let's go back to that example of the malaria rate in a densely tropical portion of Indonesia. Now remember that we have 30 villages, and each village is more or less similar to the next. Each village has about 400 villagers. Now you want to create a sample, but your research budget only allows 50 villagers in your sample. Suggest a sampling method. Well, obviously this is set up for cluster sampling, but if we did cluster sampling, each village has 400 villagers, so even if we chose one cluster to be in our sample, that's already 400 people. So instead, how about we choose a number of villages, so the villages are the clusters. The villages are the clusters. So maybe we choose a number that divides 50. Like, suppose we choose 5 villages. If we choose 5 villages, and from each 5 villages, we take 10 villagers, that will give us 50 villagers. There's other ways to do it too. You could choose 10 villages and choose 5 villagers from each one of those villages. You could do, let's say, what's the number? You could choose 2 villages and take 25 people from each village. So there's whatever divides 50, that you could work with that. Okay, so we've seen the 4 types of sampling methods. Let's talk about some examples where the sampling methods used weren't exactly right. Suppose Sally wants to determine the voting preferences of New Yorkers in an upcoming election. Sally stands outside a bakery in New York for 15 minutes and asks anyone who passes about their candidate preference. Do you think Sally's method will lead to a representative sample? The answer is no. She stood outside a single bakery in New York for just 15 minutes. The people who pass the bakery may not be representative of the sample. We don't know anything about the bakery, but let's say it was an upscale bakery. Not all New Yorkers are going to pass by an upscale bakery. So she's limiting her like the pool from who she's going to pull the sample. So she's limiting who she has access to. A better strategy was to go to different businesses and maybe also parks, things like that, to build her sample. But just going to one bakery for 15 minutes, she's really limiting herself. So this is called convenience sampling. So the definition for convenience sampling is when we create a sample where individuals who are easily accessible are more likely to be included in the sample. Convenience sampling tends to produce biased data. What do I mean by biased data? That's any data that doesn't accurately describe the population. Convenience sampling is commonly used by businesses due to its low cost. You can see with Sally in that last example, she didn't have to put in a whole lot of effort. She just had to go to one bakery. She didn't keep things random. So, and to keep things random takes effort. So usually convenience sampling is a low cost method. Let's see another example. Suppose you want to know how Americans feel about gun control. You get a host of a local talk show to ask viewers to call in about their feelings on gun control to build your sample. What kind of sampling method is this? And who do you think will respond in the talk show? Who's going to call in? Do you think these respondents are representative of the population? So this is convenient sampling. She goes to one local talk show and asks people to call in about their feelings, right? She's not putting in a lot of work. Who's going to respond? People with strong opinions are going to call in about their feelings on gun control. Whoever's watching this show, they're either going to say, oh, I really support gun control, or I really don't support gun control. So these are the type of people who are going to call in to express their feelings. That may not be representative of the whole population of Americans. This is something we call voluntary response bias. That's when the sample consists of people who volunteer to respond because they have strong opinions on an issue. Such a sample tends to not be representative of the population. Let's see one more example of a biased sampling method. Now, you're a restaurant owner and you want to collect data on the diners at a restaurant. You randomly select 1,000 restaurant diners. This is from the population of all diners to fill out a survey. Okay, starting off, this sounds good. You're randomly selecting 1,000 restaurant diners. Now you give these 1,000 restaurant diners the survey, but only 358 fill out the survey. Do you think these respondents are representative of the population? I would say this is not representative. Again, we have a similar problem to the last one, where usually people who fill out a survey they have strong opinions about the food they had, whether they enjoyed the dining experience. This is what we call non-response bias. It's when the individuals in the sample are allowed to choose to participate. The responses may not be representative of the population. So the difference between voluntary response bias and non-response bias is that in the very beginning of the last example, we didn't randomly choose people. We let people volunteer to be in the sample. In this example with the restaurant diners, we already chose people. We said, hey, you guys are in the sample. So they didn't get to choose if they were in the sample or not, but they did get to choose whether or not they wanted to fill out the survey and turn it in. Okay, so that's the difference. They just chose not to respond and not to participate in the survey. This is a common problem. So you can imagine if you're a business, if you give somebody a survey, there's a good chance they're not going to fill it out. So how can we get everyone to fill it out? Well, maybe we can create some incentive. You might see that they're paying people to fill out a survey. Maybe there's like a raffle or something like that to entice people to fill out the survey. Okay, so we're going to stop there and we will finish this section in the next video.